Lesson 19, Interpreting Correlation. In this lesson, I'm going to teach you how to use your graphing calculator to determine the correlation coefficient of a given set of data. And then we're going to interpret the correlation coefficient to determine the strength and the direction of the linear relationship. Oh, if you haven't done so, open your book up to page 129. Okay, positive and negative linear relationships. Linear relationships can be described as either positive or negative. Below are two scatter plots that display a linear relationship between two numerical variables x and y. So we have plot 1 and plot 2. The relationship displayed in plot 1 is a positive linear relationship. Does the value of the y variable tend to increase or decrease as x increases? If you were to describe this relationship using a line, would the line have a positive or negative slope? Okay, so looking at plot number 1, if we were to use a line to describe this relationship, that would be an increasing line. So it would have a positive slope. So we have a positive slope. And what that would mean is that as x increases, so as values of x get bigger, then the values of y also get bigger. So as x increases, y increases. Okay, the relationship displayed in scatter plot 2 is a negative linear relationship. As the value of one variable increases, what happens to the value of the other variable? If you were to describe the relationship using a line, would the line have a positive or negative slope? So again, in this one, if I were to draw a line, the slope would have a negative, or it would be a negative slope. So what that means is x increases, gets bigger, so notice how the number line's been 20, 30, 40, so it's getting bigger. The y values are getting smaller. Okay, so in this case, this one would have a negative slope. And what that means is that as x increases, y decreases. Okay, so what does it mean to say there is a positive linear relationship between two variables? So first of all, linear means that you can use a line. So linear means that there's a line that best fits positive means that it's increasing, or it has a positive slope. It's increasing from left to right. Or we could also say, as x increases, y increases. Okay, what does it mean to say that there's a negative linear relationship? So again, linear is a line. As opposed to not a curve. Wrong. And then negative that means that it decreases left to right. And or we could also say that as x increases, y decreases. Okay, example 2, some linear relationships are stronger than other linear relationships. So if you look at the two plots below, they both show a linear relationship between x and y, but one's stronger than the other one. Okay, it says in question number 5, is the linear relationship in scatter plot 3 positive or negative? It would be positive. If I were to draw a line, the line would be going up. Is the linear relationship in scatter plot 4 positive or negative? And again, if I were to draw a line that would best fit number 4, the line is also going up. So it would also be positive. It's also common to describe the strength of the linear relationship. We would say that the linear relationship in scatter plot 3 is weaker than the linear relationship in scatter plot 4. Why do you think that the linear relationship in scatter plot 3 is considered weaker than in linear relationship in scatter plot 4? So if you look back at those again, why do you think that 3, this one here, is weaker than scatter plot 4? If you're thinking to yourself because the points are more spread out away from the line, then you are correct. Okay, so plot 3 points are more spread out. So it's considered to be weaker. The closer the points are to making an actual line, the stronger the relationship. Okay, why do you think scatter plot with the strongest, what do you think the scatter plot with the strongest possible linear relationship might look like? And I kind of just answered that question. So the one that would be the strongest, and they asked us to make one with 5 points, so the one that would actually have the strongest linear relationship is going to actually be one that is going to make a straight line. So if I were to draw my own with 5 points, being the strongest positive means going from left to right, then it would look something like this. See, that's 4 and 5. Okay, and I tried to make my points look like they would line up perfectly. Okay, so strongest possible let me add a word in here. Strongest positive possible makes a perfect straight line. Okay, on the other hand, a scatter plot that would show the strongest possible linear relationship that's negative would go from left to right going down. Okay, so they asked me to make 5 points showing a strong positive or strong negative relationship. So something like that. Okay, so strongest possible negative. Okay, strength of linear relationships, exercises 10 through 12. So consider the 3 scatter plots shown below. Place them in order from the one that shows the strongest linear relationship to the one that shows the weakest linear relationship. So looking at these 3 scatter plots, the one that looks to me like it shows the strongest possible would be plot number 7. This one looks like most of those points actually line up and show the strongest possible. So plot 7 looks like it's the strongest. So plot 7. Now, between plot 6 and 5, those are a little hard to tell. And here's plot 5. And here's plot, oops, making 2 lines at once. Some extra little lines in here. So, which one looks stronger? I'm thinking plot 6 actually might look stronger because the distances of those points are actually looking closer to the line than the distances on plot number 5. So I'm thinking it's plot 6 next, and then plot 5. In a few minutes, I'm going to actually show you how to use the calculator to find out for sure. So that's my guess right now. Okay, explain your reasoning for choosing the order in exercise 10. So my reason is plots. I went from I'm trying to come up with the best sentence. The strongest graph had the points closest to the line and the weakest graph had the points 12. Which of the following two scatter plots shows the stronger linear relationship? Think carefully about this one. It's actually a trick. They're the same. One's just positive and one's just negative. And I'll prove that to you. If I take this graph right here and oops, is that too, oh, I can't. Well, let me show you the whole thing. If I take my two graphs and I were to flip them over, it's the exact same pictures. I'll show you that again. Take the two graphs and flip them over, it's the same two graphs. One's just a mirror image of the other one. So it ends up creating it just flipped over. So one ends up having the exact same line, just one's a downward line and one's an upward line. So this one has a negative slope, and this one has a positive slope. And by looking at the lines, you can actually see how, for example, this point right here above the line is the same point above the line over there. Alright, so they're exactly the same thing. One's just going up and one's going down. Okay, so it's a trick question. That's why they said be carefully about this one. Okay, so they're actually, one's not stronger than the other. They're actually just in opposite directions. One would just be positive and the other would be negative. Okay, so we're going to look at what we call correlation coefficient. The correlation coefficient is a number between -1 and +1, including both -1 and +1. And this is how we measure to find out exactly how strong a graph is. Okay, so we're going to look at a whole bunch of scatter plots real quick. And the value of the correlation coefficient is displayed on each one of these. Okay, so this first one, for example, that's a perfect scatter plot. It makes a line. And its correlation coefficient, which we call R, the R value is the correlation coefficient. And in this case, it comes out to exactly 1 because it's a perfect 1. So the closer you are to 1, the better the fit. So the correlation coefficient is 1 because it's perfect. Okay, here's some more. This one, the correlation coefficient, comes out to 0.7. This would be considered a strong relationship. So this one's strong. This one, however, is 0.3. This one's considered to be a weak relationship. 0.3 is. Okay, now we're on the negative side, but it's -0.1. So that's still considered to be a weak relationship. I'm going to show you a chart in a few minutes of how I know this. Okay, they're pretty scattered. The closer you get to 0, the more scattered they are, and the relationship's not very good. Okay, -0.3. That's, I believe, if I remember right, that's a weak relationship also. Now, when we get to -0.6, that one's considered to be a moderate relationship. It's a negative graph, so that means that a negative line would fit this. But notice that the points are very widely dispersed around the line, so it's only moderately fit. And then -1 is the perfect negative graph. Okay, I'm going to show you how we get these numbers. exercises 13 through 15. I feel like we're missing something here. When is the value of the correlation coefficient positive? Oh, so positive would just be between, positive would be when there's a positive relationship. And then when the value of the correlation coefficient is negative, that would be when there's a negative relationship. Okay, is the linear relationship stronger when the correlation coefficient is closer to 0 or to 1? It would be stronger when it's closer to 1. Closer to 1 or negative 1, depending on if it's a strong positive or a strong negative. Okay, looking at the scatter plots in example 4, you should have discovered the following properties. Okay, so talking about the signs, the positives and negatives. So when it's positive, it corresponds to the linear, the positive or negative corresponds to the direction of the relationship. Positive 1 means that it's perfect, which I kind of pointed that out. Negative 1 means that it's a perfect negative graph. And the closer to the value of 1 means the stronger relationship. I was kind of saying those things as we went through them. Okay, so I'm going to show you how we're going to use our graphing calculator in a couple minutes to calculate the value of the correlation coefficient. There is an equation that can be used to calculate the value of the correlation coefficient given data on 2 numerical variables. We're going to use, using this formula is a lot of tedious calculations, and they're discussed when you get to like a later statistics class. But we have our graphing calculators that can be used to find the value of the correlation coefficient once you enter the data into your calculator. So I'm going to show you how to do that. Okay, so here's some data in the previous lesson about the 10 men in their shoelace. So we're going to go ahead and we're going to enter that data. So we're going to enter that data into our graphing calculator. I gotta turn mine on. I haven't used it yet today. Alright, I'm going to go ahead and clear my memory because I don't know what's already in my calculator. Every time I get my calculator for the first time, I like to clear it. Just that way if there's some old stuff in there, I don't want it to interfere with what I'm doing. So that's always a good thing to do. Alright, so to put my numbers in my calculator, I'm going to go to Stat and enter. You guys should already know how to do this. 12.6, 11.8, 12.2. Oops, I've noticed my 11.8, I did think decimal, so I'm just going to take that one over again. Ready, 11.6. 12.2 again. 11.4. 12.8 again, 12.6, 0.8 after 11.4, so 12.2, 12.6, 11.8. Okay, those were the shoelaces. Oh, that's green. Cool. Like where I was at the table. Okay, I'm on A1, so I got the 11.4, the 12.8, so I'm on 12.2, 12.6, 11.8. Okay, now I need to go over and put in list 2 the heights of the guys. So 74, 65, 71, 67, 69, 68, 70, 69, 72, and 71. And if your 2 columns, list 1 and list 2, they should match up. If they don't and you forgot something, you need to enter that in. If you need help doing that, make sure you ask your teacher. Okay, so I have everything in. I'm going to quit, get out of this. So second mode. I'm going to clear this screen. Okay, so what we need to do in order to get the correlation coefficient to show up is we need to go into the catalog, which to go into the catalog, what you need to hit is the second key and the 0 key. Okay, so second and 0. You'll notice above the 0 it says catalog. And then you can either scroll over looking for, because we're looking for diagnostics on. You can either scroll all the way down to diagnostics on, or if you'll notice up here at the top, it does say, oops, right on my calculator, it does say that the alpha is locked. That's what this stands for, alpha lock. So you could hit the alpha D key to jump down to the D's a little faster, which the alpha key is the X, X of the -1 key right here. And that'll jump you down to the D part of the catalog faster, so you don't have to scroll all the way down from the A alphabet. Now you'll jump down to the D's, and then you'll just look for diagnostics on. Once you get there, oops, there I got to diagnostics on. So you're looking for diagnostics on. Once you get there, then you're just going to push enter twice. And then it'll be turned on, and then I'll show you what that means. So I'm going to hit enter, enter, and it'll say done. Okay, so now, after you get done doing that, you turn them on. You won't have to turn it on again until the next day when you go to use your calculator again and you want to find out the correlation coefficient. So now that I've turned it on, I'm going to get the equation of the best fit line. Okay, so it says enter the shoe length, the height in your calculator, find the value of the correlation coefficient. So to do that, we're going to actually find the equation as well. When you go to find the equation, this time there's going to be more information than that's been in there in the past. We're going to do our stat, go over to calculate, and pick option number 4 like when we find the equation, but there's going to be extra information in there. Okay, so here's the information that we usually get. But notice this time there's this R value, not R squared, but R. That R value is telling you the correlation coefficient. R value, and in this case it's 0.65. And that R value is how well, in this case, the shoe length and the height are related. And if we look at this chart right here, it tells us how I was getting that information. It tells us if, well, when R is 1, that was a perfect relationship. When R is between 0.7 and 1, it's a strong relationship. If it's between 0.3 and 0.7, it's moderate. And if it's between 0 and 0.3, it's weak. And then same thing goes on the negative side. So 0 is no relationship. And then on the negative side, it's the same exact thing. And that's how I was labeling the graphs, because I had this pretty much memorized. After you look at it a few times, you start to know. So in this case, because it's 0.6, 0.6 would fall in here between 0.3 and 0.7. So this would be a moderate relationship. Okay, so it says interpret the value of the correlation coefficient between the shoe height. Okay, so it's a moderate relationship. Okay, and last thing they want us to do is one more. So we would put all those numbers in again into the table, and then we would calculate the equation. But we're not really looking for the equation this time. We're just looking for that R value to see how strong the relationship is. So again, I would go to my calculator, go to Stat, put all those numbers in. So I got to clear my old list. And put those new numbers in. So 2, 5, 3, 3.5, 1, 2, 3, 6, 3, 5, 3.5, 2.5, 0, 1, and 3. And then over here, 268. So we're looking at the relationship between fat and calories of something, I didn't read it, 303. Oh, darn. 260, 300. Usually the more fat, the more calories. So there's usually a pretty good relationship. 160, 200, 320, 420, 290, 285, 390, 140, 330, 120, 180. Either I have an extra or I forgot one, because my lists aren't the same size. Oh, there's not a 160 up here. So that's an extra one. Okay. So I'm going to quit. I'm going to act like I'm calculating my equation, number 4. And I get this R value. Well, I thought it would be a lot stronger than that. I wonder if I had my numbers in the right order. Trying to do this one faster. 2, 268, 5, 303, 3, 260, 3.5, 200, 1, 315, 2, 200. Wait, 2 is supposed to be the 160. Let's go 160 away. 3 is with 200, so it looks like I messed up. 6 is with 320. 3 is with 420. 5 is with 290. 3.5 is with 285. 2.5 is with 390. 0 is with 140. 1 is with 120. And 3 is with 180. Okay. That's should fix it, make it sound a lot better. Stat, help, and number 4, enter. Oh, it's still only coming out to about 0.4. Okay, it's a little higher, but not much at all. Okay, I'm really surprised by this actually. It's only coming out to about 0.46. So it says, based on the scatter plot, do you think the value of the correlation coefficient between fat content and calories per serving would be positive or negative? So it came out to be positive. Which, looking at the graph, I would have guessed that, because this is going up. But I'm really surprised that it only came out to about 0.4. So it came out to R is equal to 0.46, which is moderate. Which I'm really surprised. I thought it would be a lot higher. Okay, and then there's another one. I think we've actually done enough to see how to do it. If you have any questions on how to use the scatter plot, please feel free to ask. Okay, well that's the whole idea. This is only moderate, like I said. I thought it would actually be a lot higher of a relationship, a stronger relationship. Okay, and that's what today's lesson's about.